Welcome back, STEM students, to Mampaisan's online classroom. Today, we're going to have the part 2 of our discussion of waves and sound. For part 1, we've already discussed waves, so today we're going to focus on sound propagation. Yeah. Of course, one of the big ideas that we should have in mind is that sound is a form of energy that spreads out through space. Take note of the word spreads out. We know naman that it is synonymous to propagate, right? Ayan. And we know previously that sound is a mechanical wave, and additionally, sound is also a longitudinal wave. No? So, ibig sabihin, kailangan niya ng medium and kailangan ang movement niya ay parallel to the movement of the medium. So, all sounds originate in the vibrations of material objects. So, there should be a material, and that material for sound to be produced, it must be vibrated or it must be vibrating. No, I underline the word material because it emphasizes the fact that sound waves are mechanical waves. And then, as sabi dito, as a source of sound vibrates, a series of compressions and rarefactions travels outward from the source. So may compressions, may rarefactions, and we know that these are parts of a longitudinal wave, which emphasizes the fact that sound waves are longitudinal waves. Yeah. So here is an illustration that shows us how a specific source, in this case a speaker, creates disturbance so that the air molecules will be able to serve as medium so that the energy would be able to reach the receiver. Syempre, yung speaker is the source and the receiver, yung mga taong may tenga at may kakayahang makinig. Okay? Hindi lang naman syempre tao yun, no? Pwede ring animals. Plants, di tayo sure kung nakakarinig sila, no? Ayan. So most of the time, the medium that sound waves travel or pass through are air molecules. Okay? Most of the time. Pero pwede rin siya sa solid, pwede rin siya sa liquid, no? Ayan. So here are some specific sources aside from a speaker. We have here the voice box. Notice that if you try to put your hand towards your throat where the voice box is located, sa harap yun ng iyong throat, no? And then you try to speak, you will feel the vibrations inside, no? So, ang ginagawa niya dyan ay dinidisturb ang air particles. Okay? And then, we know also that string instruments are vibrated or we disturb this so that it would vibrate and it will produce a sound. And ganun din sa mga wind instrument. Actually, pati sa percussion instrument, no? They are disturbed so that waves would be created and energy would be transferred in the form of sound energy. Now, how are we able to perceive sound? First, of course, there should be syempre a source, and then this one is the ear of the receiver, no? And then from the source, let's say we have a speaker here, tapos the energy that it comes from the speaker, the goal is to let it through the ear of the receiver, no? So between the source, ito yung source natin, and the receiver of the energy, there are air particles. Sometimes, maririnig mo pa rin yung mga tao or yung mga speakers when they are in the other room. So, may solid sa pagitan ninyo. Okay lang din yun. Kahit may aquarium sa pagitan ninyo, minsan naririnig niyo pa rin. Kasi nga, as long as there is matter, solid man yan, liquid man yan, or gas, sound will still travel, no? So, ito yung source natin. Tapos, gagawin niya, most of the time, i-disturb niya yung air molecules or air particles, gas particles, okay? And then, the energy will be transferred from one molecule to another until it reaches the air molecules here sa ear canal, no? Ayan. And then, or auditory canal. And then, the energy will pass through sa eardrum, tapos papasapasahan na ito yung mga major na nagko-cause ng dinadaanan rather of the energy. So from the air particles in the ear canal, nagbabibrate yan sila dyan. Siyempre pag nagbabibrate, there is movement, tatama or magko-collide yung ibang air particles dito sa ating eardrums, no? And then the eardrum will vibrate so that it will be able to transfer the sound energy sa three smallest bones in our ears, yung hammer, yung anvil, tsaka yung stirrup. Or in scientific term, it's the malleus. Sorry kung mali yung pronunciation, bio kasi ito no? Ayan, yung incus tsaka yung stapes. And then after dun sa three smallest bone, the energy will be transferred towards the cochlea, which contains liquid, and then magbabibrate din siya at magbabibrate din yung liquid dito sa loob niya, and the information will be passed through the auditory nerve. The auditory nerve will pass the information papunta sa brain, and then the brain will interpret what you have heard, no? Ayan. And then, after that, well, let's discuss the properties of sound. Here are the four particular properties of sound that we're going to discuss in this lesson. The first one is pitch, and we have loudness, interference, and speed. Okay? Ayan. So before we proceed to discussing one by one those particular characteristics or properties, let's have this wave diagram. When we say wave diagram, we know naman that sound is longitudinal. So, dapat ganito yung itsura niya, di ba? Ayan. O kaya mukha siya dapat na spring. Now, in a wave diagram, it can be reinterpreted or illustrated as a transverse wave wherein these compressions are equivalent to crests, while the rarefactions are equivalent to troughs. Okay, ayan. Usually, ito yung makikita natin sa mga, yung mixer ba yun? Yung may lumalabas-labas na, sa speaker, may taas baba na ilaw. Ayan. Okay, so dun sa mga tumataas yung ilaw, dun compressed yung, air particles. And then, dun naman sa mga parts na medyo mabababa yung level, ito naman yun, sa trough naman siya. So, wag yung magtaka kung makikita nating mga waves dito ay hindi illustrated as longitudinal wave, but instead, they are illustrated using a wave diagram para mas madali natin silang ma-visualize, no? Lalo na sa part ng interference. Ayan. So, let's start with pitch. Pitch is the perception of a frequency. The perception of a frequency is commonly referred to as the pitch of sound. A high-pitched sound corresponds to a high-frequency sound wave, and a low-pitched sound corresponds to a low-frequency sound wave. So sometimes pitch is also defined as the highness or lowness of sound, and it is dependent upon the frequency. Ngayon, anong pinagkaiba ng frequency sa pitch? Frequency can be measured using a specific instrument. I just forgot. It's a detector, no? Ayan. However, pitch is dependent upon the listener. So, syempre, kapag high frequency ang ating source of sound, pag mas malapit ka, para sa'yo, mas mataas yung pitch. Pero kapag mas malayo yung observer sa source ng sound, later makikita natin yun sa Doppler effect, mag-iiba yung perception, no? So iba-iba tayo ng perception ng pitch depende sa lapit o layo natin sa source of sound. However, the frequency remains the same, okay? Ayan. So ito yung wave diagram to show us what high frequency wave looks like and how low frequency wave looks like. No? For high frequency wave, we have several waves occurring at the same time interval. So same time interval yan. Ha? Ayan. So mas maraming wave per time interval, equal lang yung time nila. Kapag low frequency naman, mas konti yung waves or wavelength per time interval. Okay? Tapos, notice din na yung period or the time it takes to complete one wavelength is shorter sa high frequency waves. Tapos, sa low frequency sound waves naman, mas malaki yung period or yung time it takes to be able to complete one wavelength. Umuulan na, okay lang yan. Sana naririnig niyo pa ako, no? Ayan. Sound waves with frequencies below 20 Hz are called infrasonic, while sound waves with frequencies above 20,000 Hz are called ultrasonic. Infra means the lower than, it's a prefix that means lower than, tapos ultra naman means above or greater than. Pero anong basis natin para masabing higher or lower? Yung normal human being kasi, normal ang sinabi ko. Siyempre yung mga bingi, iba naman usapan yun kasi baka pilosopohin nyo ako, no? A normal human being is able to hear sounds from 20 Hertz with frequencies from 20 Hertz to 20,000 Hertz. So ito yung basis nun. Yung mga sounds that is lower than the frequency that a human can hear, they are infrasonic. And then, yung mga sound naman that is higher frequency compared to what human beings can hear, they are the ultrasonic ones. Now, here's an illustration that shows us some of the frequency ranges that several organisms are able to hear. So, yung elephant, mole, yung elephant saka mole, they are able to hear sounds that are lower than the frequencies that humans can hear. Ito, nakita mo, humans, 20 to 20,000. Okay? Mga pusa naman are able to hear sounds with higher frequencies until 40,000. Ayan. Okay. Ito na palang elephant tsaka mole hanggang greater than 160,000 hertz kaya nilang marinig. Tapos yung mga dolphins naman at saka mga bats, they are also able to hear ultrasounds. Pero there is a specific range that they cannot hear anymore, but humans can hear. Ayan. Ito mga cat dog natin, mga masyadong sensitive sa sound. Okay? And then the next property of sound is loudness. The amplitude of a sound wave determines its intensity, which in turn is perceived by the ear as loudness. So just like pitch, loudness is subjective, no? Siyempre kapag mas malapit ka sa source of sound, mas malakas para sa'yo yung sound. Pero pag lumayo ka, the tendency is mas mahina para sa'yo yung sound, okay? But it also depends upon the amplitude and the intensity of the sound. Sound intensity is objective, ayan, and is measured by instruments. Loudness, on the other hand, is a physiological sensation sensed in the brain. Ayan. Siyempre kapag damage na ang ating ears, medyo iba ang dinig natin, no? Ayan. So here, mayroon ulit tayong illustration of of how sound waves would look like if the sound is high intensity and if the sound is low intensity. Again, it is dependent upon the amplitude. Notice, ito yung una, yung bird natin, nag-chirp-chirp lang siya, no? Tapos dito, angry bird na siya. Ayan, nagalit na siya. So, malakas na yung kanyang boses. Malakas, hindi matinis. Kasi pitch is matinis in Tagalog. Excuse me. Loud naman is malakas. Diba? Ayan. So dito sa una, as the bird is just chirping, no? Notice that the amplitude is very small. Again, ito yung amplitude natin. Ayan, distance from equilibrium position to a crest or a trough. And then, nung sumigaw na siya, nag-angry bird na siya, ayan, lumaki na yung amplitude niya. Ayan. So, louder na siya, no? So if you're going to listen to these birds at the same distance, you will be able to hear that this angry bird shouts or chirps louder compared to the first bird, no? Ayan. Sound intensity, also known as acoustic intensity, is defined as the power carried by sound waves per unit area in a direction perpendicular to that area. Okay? Ayan. Tapos sound intensity level naman on the other hand is a logarithmic expression of sound intensity relative to a reference intensity. Ayan. So kapag sound intensity, ito measured by a device and no standard or walang reference as intensity, ayan, and it is the power carried by the sound per unit area. Tapos, syempre, dahil nga longitudinal, may nakita kang perpendicular dyan, no? Longitudinal. So, let's say ito yung ating wave, no? Mukha siyang spring. Ayan. Tapos, ito yung area kung saan siya ay magpa-pass through. Perpendicular nga naman sila, no? So, nakadepende daw siya sa area at saka sa power na kinikerry ng ating sound. Although, I will not show the mathematical stuff na there para hindi na kayo masyadong mahirapan sa finals natin, no? And then, iba siya sa sound intensity level, which is measured in decibels, because there is actually a threshold or reference for specific organisms yan. So sa tao, ito siya. Oh. Ang hearing threshold natin for humans is 0 decibel. Pag mas mababa dyan, di mo na siya marinig. 10 decibels yung normal breathing. Close whisper, 20 decibels yun. Ayan. Tapos yung jet, ayan yung pinakamataas, 140 decibels. Medyo nakakabingi na tong part na to. And then you will see here the threshold of pain, which is 120 decibels. When we say threshold of pain, it is the sound level, sound intensity level, wherein the ear will start to hurt when you hear sounds like this. So yung mga jet engine, kaya talagang parang masakit na siya sa tenga natin kung tutuusin ay dahil mas mataas na siya sa ating threshold of pain. Tapos itong loud rock music, ay nako talaga yung mga loud rock music na yan, no? Oh, 150, 115 decibels, malapit na siya sa threshold of pain natin. Ayan. Now, here's an illustration that shows us the difference between a pitch and the sound. Hindi porke high-pitched, loud na. Diba? Hindi naman porke low-pitched, hindi siya loud. Okay? Nakadepende yon, no? Ayan. Difference between pitch and loudness. Loudness increases the amplitude or decreases the amplitude. Ayan. Tapos, kapag pitch naman, ang ini-increase niya, ay dinidecrease niya ay ang frequency. Ayan. Tapos dito, nag-i-increase naman. Pag yung pitch ay nag-i-increase, yung frequency ang nag-i-increase as well. Ayan. So, pitch is frequency dependent, while loudness is amplitude dependent. Okay? Ayan. Again, salamat. Sabi kasi dun sa kailangan i-claim na galing sa slides go ang ating template. Ayan. Thank you for listening again and see you sa part 3 ng ating sound waves or waves and sound discussion. That's all for today. See you in part 3.